Hi, this is Miss Oliva, and I'm going to go over material from 2.3, which is about long division and synthetic division and the remainder theorem with polynomials. So let's get started. Okay, so long division, if you haven't done it in a while, is going to be a little tricky. So just go along with me. First of all, you want these in order from highest to lowest before you do anything else. And if something's missing, you want to put a 0 there. So I have an x to the 4th, but I don't have an x to the 3rd. So I'm going to put a 0. I have an x squared, but I don't have an x by itself. So I'm going to put 0x. So this is what I'm going to be using to divide by this. So the 2x minus 4 goes on the outside. And all of this goes on the inside. Hopefully I'm not going to run out of room. And then the way you start is you say, you just look at the first terms first, okay? And you say, what would I need to multiply this, the 2x by, so that it would become 6x to the 4th? Well, we would definitely need a 3, because 3 times 2 is 6. But we would also need some x's, because I only have 1, and I'm trying to get to x to the 4th. So I would need 3x to the 3rd. So whatever you pick, you're now going to multiply by each thing out front, each term out here. So 3x to the 3rd times 2x gives me 6x to the 4th, which is good. That's what I wanted. But this times -4 gives me -12x to the 3rd. Do you see why we put the 0 there? So that it would be lined up correctly. So we pick what goes here, we multiply it by everything outside, and now we need to subtract, but you need to be careful because we need to subtract this, and we also need to subtract this. So this gives us nothing, and that's what we wanted, but we have to be careful here. 0 minus a -12 really becomes a plus. And then we bring down the next term, and we do all of that again. So now what would I have to multiply 2x by to get to 12x to the 3rd? So it would be 6x to the 2nd, right? Because 6 times 2 is 12, and I would need x to the 2nd to multiply by x to get to x to the 3rd. So 6x squared times that, and then times -4. If I subtract here, they wipe each other out. If I subtract here, it becomes -20 minus a -24, so that becomes a plus. So I really get 4x squared. And now I bring down the next term. So I'm going to take that over here. I'm running out of room. Okay, so what would I need to multiply 2x by to get to 4x squared? I would need a 2, and I would need an x. So now I multiply. 2x times 2x is 4x squared. Good. 2x times -4 is -8x. This wipes out. Don't forget you're also subtracting here. So 0 minus a negative really becomes a plus. And then we bring down the next term, which would be the -16. What would we need to multiply 2x by to get to 8x? That would be a +4, which would give me 8x minus 16 minus wipes out minus wipes out. So I have no remainder. So this is my final answer. If we did have a remainder, we would have written it up here as a fraction, the remainder over what we were dividing by. I'm sure we'll see that in a minute. So if you want to pause and try the next one, you can go ahead, but be careful. Make sure you see there's a missing x to the 3rd here, and there's also a missing x here. So you're going to need to put a 0 and a 0 in those spots. So that goes outside and this goes inside. There's no x to the third, so I need to put a 0x to the third. And there was no x on the outside, so I had to put an x. Okay, what would I need to multiply by to get from x to the second to x to the fifth? I don't need any numbers this time, but I do need an x to the third. Because remember, when you multiply these, you really add the exponents. So that will give me an x to the fifth. This times 0 is just going to be 0. This times 5 is going to give me 5x to the third. Subtracting is gone. Anything minus 0 is just going to be the same thing. But be careful here, because if you do this fast, you're going to put a 5. But really, remember, it's 0 minus this, so it becomes a negative. So most of the mistakes are made because of this step. So you need to find some system where you're always going to make sure you're subtracting every single thing carefully. I'm going to bring down the next, which seems weird because it's going to give us 3, but that's fine this time because we have 3 on the outside. So we want 3 terms each time. So now x squared times what would give me 5x to the fourth. Well, this time we do need the 5, and we also need 2 more x's. So I'm going to multiply by 5x squared. That gives me 5x to the fourth plus 0 plus 25x to the second. Make sure you're subtracting each thing. So that goes away. This just stays negative 5x to the third. But here I need to be careful. 7 minus 25 is negative 18. X to the second. Bring down the next term, and we go again. This time I need to multiply by negative 5 and an x. Multiplying gives me negative 5x to the third plus 0, negative 25x. I need to make sure I'm subtracting each thing. So here I have a negative 6 minus a negative 25. So those become a plus. So negative 6 plus 25 is going to be a positive 19x. And then I bring down the negative 90, and this should be my last time. So what would I have to multiply x squared by to get to negative 18x squared? I would only need the negative 18. So now I multiply. And 18 times 5 is 90, so that works out. So these are gone. This is going to be 19x, and this, because it's negative 90 minus 90, wipes out. So my remainder is just the 19x. So here's where we need to learn how to write a remainder. We just say plus. We make a fraction where we put the remainder on top and whatever we were dividing by on the bottom. So I'm just going to write x squared plus 5 because I don't need the 0 there. If you put it, it's fine. You just don't need it. So that's my final answer. One more. So if you want to try this one before I do, pause and try it. Make sure you know that the top thing goes inside and the bottom goes outside. There's no x squared and there's no x. So I need 2 zeros inside. What would I multiply x by to get to x to the third? Then keep on going. Gone. Be careful here. X 0 minus a negative really becomes a plus. Bring down the next term and we start again. What would I need to multiply to get to that? A positive 4 and an x. Multiply and multiply. Now subtract and subtract. Gone. This changes to a plus. Bring down the negative 64, and we go one more time. What would I have to multiply by? Positive 16. That would give me 16x minus 64. So no remainder. And that's my answer. So that is how you do long division with polynomials. Next is a different type of division that most people think is weird at first, but most people end up liking this better because it kind of gets rid of all those x's that can get in the way. It's kind of like a shortcut version of what we just did, and it's called synthetic division. And you can only do it if you're dividing by something in the form of x minus a number, which means it can also be x plus a number, just that number would be negative, right? So basically it needs to be something simple, x and a number, not a bunch of other stuff, not an x squared, nothing like that. So is this simple enough? Yes. But what would that mean the c is? If it's supposed to be x minus the number and I have x plus, doesn't that just mean that the c must be -7? So basically, if they give you a factor, which is what this is called, x plus a number or x minus a number, you're always going to put the opposite out here because we want to put the c or the 0. If x plus 7 is a factor, doesn't that mean the 0 would be -7? So it's the 0 we use in synthetic division. Next thing we do is instead of putting the whole equation in here, we just put the numbers. So 4 for 4x squared, 24 for 24x, and 20 for the constant. If something was missing, I would put a 0. Okay, how do we do synthetic division now that we set it up? So we took the opposite of this, put it outside, and then just put the coefficients in here. Well, you will always just bring the first one down. Then you will multiply times what is out front, 4 times -7. And then instead of subtracting like we did with long division, we're going to add. Multiply again, and then add. What this means is whatever x we were here, since we're dividing, if that was an x to the 5th, it would now become x to the 4th. But since that's only an x squared, this becomes 4x minus 4. And the last one I usually box to remind myself that's the remainder. So we write that as a fraction divided by what were we dividing by? We weren't actually dividing by -7, right? We were really dividing by x plus 7. So let's try it again. First, maybe rewrite this so it's easier to take the numbers. So write it in order, and if something's missing, put a 0. And remember that you're going to do the opposite. So -2 is what comes out. And then -2, 3, 0, 8, -4. Bring down the first number. Multiply, add. Multiply times, we're always multiplying by this. So 7 times -2, and then we add. -14 times -2, and then we add, times -2, and then we add, box that one to remind yourself that that's the remainder. So what was the highest power when we started? X to the 4th. So now this should be 1 power less. So -2x to the 3rd, and then it just keeps on going down. Plus 7x to the 2nd, minus 14x, plus 36, plus -56 over what were we really dividing by? So do you see it's kind of like a shortcut? We get rid of all the x's and just deal with the numbers, but then at the very end, if they're asking you the answer, you need to put those back in. All right, another way to use synthetic division, instead of to find your quotient, which is what you find when you divide something, is there's something called the remainder theorem that says that if you're trying to find a value of a function at a certain number, so if this is k of x and I want to find k of 3, we all know we could just plug in the 3, right? But sometimes that takes a little while and sometimes it's tricky. So the remainder theorem says, instead, you can take the 3, and since that is an x value, you don't change it, put it on the outside, and do synthetic division. Whatever you get as your remainder is the answer to k of 3. So bring down the 2, multiply by 3, add, multiply, add, multiply, and add. So k of 3 apparently is negative 21. Okay. But now let's see some of the more difficult types when it's not a nice number, when it's either a fraction or like a square root. So if 9 over 2 was out here, how would we handle that? Let's see. First, we just bring down the 2, so that's nice. Then we multiply these, but what's nice is if you're doing 9 over 2 times 2, the 2's just wipe out. So that would just be 9. Negative 9 plus 9 is 0. 0 times anything is 0. Add these and you get negative 4. And so now you just have to do 9 halves times negative 4. Whoops, this should be a 1. So again, the 2 and the negative 4 will reduce, and then we can go from there. Okay, sorry, let me get back. Okay, so the last step is we were doing the 2 or the 9 over 2 times the negative 4. That's a 1 on the bottom. We could reduce these to negative 2 and 1. So 9 times negative 2 is negative 18 over 1. So it actually works out nicely. And since the remainder is 0, that's what it would be. Now for the last one with the square root, I think we need a little more room. So I'm going to do that over here. So my numbers were 2, negative 9, negative 4, and 18. And we're going to use the square root of 2. So let's see how that's going to work. Bring down the same first number. 2 times square root of 2 is just 2 square root of 2. You cannot multiply those and get a 4. And then when you go to add, you also can't add these because you can't add a normal number with something with a square root with it. So it's just going to become negative 9 plus 2 square root of 2. But now I need to multiply that by square root of 2. So I'm going to do that down here so you can see. So distributing, I get negative 9 square root of 2 plus 2. Now you can multiply these to get square root of 4, which is a nice number. So this is really a 2 times a 2, so 4. So we're going to say 4 minus 9 square root of 2. So when I go to add these, I'm only allowed to add the negative 4 and the 4. And when I do that, they wipe out. So I really only have the negative 9 square root of 2 left. And then now I need to do square root of 2 times negative 9 square root of 2. I can multiply the 2 square roots again, and then they become a nice number again. So negative 9 times 2 is negative 18. And again, we ended up with 0. Definitely will not happen every time, but it worked out nicely. Okay. So now what if they gave us an equation and said that they want us to factor this whole equation? And you could try it right now with grouping, but it would not work. But they've given us a clue that negative 1 is one of the zeros. So what that means is we could start by dividing by negative 1 because we know it's going to work out nicely. And then we can see if we can factor whatever we have left at that point. So what are my numbers? 4, 9, negative 16, and negative 21. Bring down the 4. Since they're telling me it's a 0, I should get 0 as my final answer, my remainder, because the definition of a 0 is that you get no remainder when you plug it in. So 4 times -1, add these. 5 times -1, add these. -21 times -1 is a positive 21. And just like we thought, we get 0. But we already knew that, right? We already knew. Here's one of my zeros. So I just don't want to forget that that's one of my zeros. But what does this mean? Remember that this means we have 4x squared plus 5x minus 21 now. And since that is a quadratic, we might be able to factor that. So I'm going to try to factor it over here. So I'm going to multiply the 4 times the -21. And I'm going to start trying to find numbers that could possibly get me to 5. 7 and 12, since one needs to be positive and one needs to be negative, could get me to 5. So I want the 12 to be positive and the 7 to be negative. So now I'm going to say 4x squared. I'm going to use those two to rewrite this. This is using the AC method. Minus 7x plus 12x minus 21. And now I'm going to use grouping to factor from here. So if you're understanding all of the new stuff I'm doing, but you don't understand how to factor something like this, you need to on your own, or you can ask me if I can send you something to practice factoring, and specifically quadratics with a greater than 1. So basically a quadratic when you have a number out front. So if I did this with grouping now, what could I take out of these two? Only an x. So I'd have 4x minus 7 still. What could I take out of these two? Just a 3. But now I have those parentheses match. So I get 4x minus 7 and x plus 3. And I was trying to factor, right? So these are my factors. But be careful that you don't forget that you should have this many x's, right? I only have 2, and it's because I'm forgetting that I already did this. I already divided out that -1, which meant that -1 came from another factor. So what factor would give me -1 as my solution? X plus 1. Right? So the factors and the zeros are always opposite. So here is my factored form of the equation, which means the solution set is what I would get if I set each of these equal to 0 and solved. So here, be careful, you'd have to add the 7 and divide by 4. This one would be -3, and that would be -1, which is the one they gave me. Okay? So finally, write a polynomial, f of x, that meets the conditions. It's degree 3, so again, there should be 3 x's in there some point, with zeros 5, -6, and 3. So again, these are zeros. So I can write them as 3 factors instead. 5 would mean x minus 5, -6 would mean x plus 6, and 3 would mean x minus 3. Now I just make sure that I did the degree. And yeah, I have 3. So this should be good. I could multiply this all out, but it is okay to just leave it like this. So if they give us something like these, same idea. X minus 4 square root of 3 and x plus 4 square root of 3. And you can just leave it like that. Make sure I have the degree, so I didn't miss anything. 2, yeah, that makes sense. So I think we're good. And then finally, let's be careful with this one because they, I think, are going to want this in a nicer form. So f of x, if my first one's -1, that one's easy. But the i's look a little weird, but we still do them the same way. A positive 2i, I'm going to say x minus 2i. And a negative, I'm going to say x plus. Now, I think this was the type of problem where they would now want you to go one step further with these. So x plus 1 is fine. If I FOILed that out, I'd get x squared plus 2ix, which I know is weird, minus 2ix minus 4i squared. These two end up wiping each other out. And don't forget that an I squared really means -1. So -4 times -1, that's just going to become plus. So I have x plus 1 and then x squared plus 4. Okay, that is it for 2.3. Let me know if you have any other questions.